How's my audio level, by the way?
The disembodied voice in the background needs to stop talking so that I can read a poem. How about it? All right. By the way, guys, you can surely see my face. I'm doing something a little different here today. Instead of sharing the screen to read a poem, let us instead actually have a poem that is that I'm reading from this book. So I have this book here of poetry, astronomy poetry and prose, called More Things in Heaven and Earth by David H. Levi. All right. And so Levi, this book was actually written by the guy who Shoemaker Levi 9 was named after, amazingly enough. He's one of the world's best known astronomers and discovered over 21 comets, and 8 of them using a telescoping and backyard observatory he built. So, and he, I guess, he's also quite the poet, or he has definitely a poetic flair to him. So he wrote this book. So this poem I'm going to read is not written by him, but it's one of the many poems in this book. No idea what it's called, but I liked it. So here goes, without further ado. Plainness and clearness without shadow of stain, clearness divine. Yea, heavens whose pure dark regions have no sign of languor, though so calm and though so great, are yet untroubled and yet unpassionate, who, though so noble, share in the world's toil, and though so tasked, keep free from dust and soil. I will not say that your mild deeps retain a tinge, it may be, of their silent pain, who have longed deeply once and longed in vain, but I'll rather say that you remain a world above man's head, to let him see how boundless might his soul's horizon be, how vast, yet of what clear transparency, how it were good to abide there and breathe free, how fair a lot to fill is left to each man still. All right.
Wow.
If you overly poetic ways of saying, look at the beautiful sky and how vast and boundless it is. All right. I think that's what it means.
But what are we doing?
But so says the disembodied voice. What are we doing? Well, SG2 on Space. You're listening to the only weekly space show. I may have lied slightly. We did not do a show last week. If we're super motivated, we might do another show later this week to catch up for that. Who knows? We'll see. So I'm Shen, SHEN, last name GE, and the disembodied voice in the background. Also, you can call me Rocket Man if you wish. Let's bring this guy, Lonard Kramer, with a headband.
Hey, Shen.
Hey, good to hear from you.
How's it going?
This is great.
Yeah.
You know what's even better is that I got these new speakers, so you sound really good too.
Yeah, I thought there was something a little bit different, and also the poem was absolutely awesome.
Here,
yeah,
I got these speakers.
Yeah, a sound bar. It's like a sound bar thing.
It is a sound bar, but I got it yesterday. Micro Center, which is great, and
cool.
And the poem, yes, because like. What's the point of arbitrarily finding a poem online when I have like 100 books of poetry that I could just take something from? I mean, I literally.
Well, you can always fall back on like Shakespeare or something.
Indeed. So the poem I read sounds very Shakespeare-ish, but
it did actually
a little bit.
Well, what's the name of the book? More Things in Heaven and Earth.
Yes. Where's that from?
I'm sure that's from Hamlet. There are more things in heaven and earth than are thought of in your philosophy.
The person who wrote this, by the way, is this guy. Here, let me see. Let me see if I can put his face up here. Matthew Arnold. He wrote that little thing. So he's he looks funny. English poet and cultural critic. He wrote the poem that I just described, which is about the sky.
It looks like a character I would meet at the Renaissance Fair or something.
You would meet this guy at the Renaissance Fair?
I don't know. He looks scary. Wow. It's not. I guess that's not. Well, he's like 19th century.
Yeah, I mean,
Yeah. Okay.
I guess this was a fashion back in the day, 1822 to 1888.
Okay. Well, so he's long gone, and he's not coming out to hunt us down or something for.
No, you're probably not going to meet him in the Rim Fair.
Right.
But before I continue, I have to say, you can support the show on patreon.com/SG2 on space. Thank you to Kyle Baker, Sam Welsh, John Grace for your kindly monthly donations. I keep a ticker running on the bottom. Of course, also thank you for Inclusa Atumra, who was my producer for over a year prior to us taking over in terms of doing this role. Now, I know I'm just blabbing, so why don't we get to the topic today? So this is episode 24.
What did you want to talk about?
I want to talk about fireballs. So, what are fireballs?
Fireballs are meteors that are very large, and they're tracked by NASA. And I think if they're above a certain energy threshold, I don't know what that threshold is, then they're entered into a database, and you can find a really awesome website where they show you a map of the fireballs that have occurred. Yeah, that's it.
So I'm going to ask you a question here. So what's the difference between a fireball and just a rock that goes into our atmosphere?
There really isn't any difference in the qualitative sense. It's more of a quantitative. So if it's above a certain threshold in energy, and these are some of these are kiloton events, then it's characterized as a fireball. And so this is a culmination or a catalog of the number of fireballs that have been tracked by an instrument on the GOES satellite, which is a Earth. It's really a weather satellite, and I think this database has been accumulated since about 2019 or 2017, something like that. And each one of those has a different size, and you can see that's the Chelyabinsk event that happened a few years ago in Russia.
What's the Chelyabinsk event?
It's a meteor that entered the atmosphere in Russia, actually that says 2013, right? So this has been I had the dates wrong, but you can see here that these are the fireballs that are reported to the U.S. government sensors. Some of them are ground-based, and so it just astonished me that they're all over the world, and sometimes they seem to be a little bit organized seasonally, and some strange things like that. And kilotons, you see that the energy content over there. So they are very large events. Sometimes
can you help explain a little bit what kilotons mean? Is that the weight?
No, that means equivalent kilotons in TNT. It's explosive power. It's energy.
Oh, wow! So this is for the Chelyabinsk event, the one that happened in Russia, in 2013 has 440 kilotons, which essentially means the energy that happened is equivalent to 440 kilotons of TNT exploding.
So it's comparable to small atomic explosions.
Right. I see.
Yeah.
That seems to be the most prominent one over here.
Now, interestingly, one time we talked about the Tunguska event, and it occurred kind of in that same area, but that was in 1908, if you remember.
Yeah, I think this one is 1988. So
yeah,
fairly recent.
It doesn't include that one because they didn't have any satellites. And so
hey, look at this. This is a lat long altitude velocity. Wow, these things are going really fast.
Yeah, so that's at orbital speed. Those are speeds comparable to the Earth's orbit around the sun. So that's kind of like of that character. If it's much larger than that, then these are events. These are objects that could be of interstellar origin. Although I think maybe only one or two of those have ever been.
So the Chelyabinsk one has 3.75 times 10 to the 14th joules of total radiated energy.
Yeah. So these are things, most people have seen a fireball. I mean, if you've seen a meteor, a very large meteor that has gone all the way across the sky, they're not common, but I think a lot of people have seen very prominent meteors. So you will have an opportunity to see them from time to time.
Ooh,
occasionally they're visible in the daytime. But this is the result of a satellite sensor that is able to resolve these from geosynchronous orbit.
That's pretty amazing. Do we now these things? Are we assuming they're always burn up in the atmosphere, or do they impact the ground as well?
It's not usual to find meteors that have reached the ground, although of course it does happen, and it's happened in over thousands of years. People have found meteors, even in in King Tut's tomb. There's a dagger made of iron from a meteor. So these kind of things they do occur from time to time, and they do reach the ground.
Wow, look at that. This is from the, I guess, what's that satellite?
Yeah.
The GOES satellites.
GOES satellite.
Lightning.
Yeah.
Map. Oh, this is Lightning Mapper?
That's lightning. Someday we can talk about the global electric circuit.
This is interesting. So it's designed to capture natural lightning activity, but it is also capable of detecting bright meteors.
Correct.
That's really interesting.
Right.
So an instrument that was designed to detect lightning also ends up being able to detect these fireballs.
And why not? Yeah.
So so these are lightning, but these are so they call these bolides. I guess that's a technical term. Yeah. And goes east, stereo goes west. Do you know what those happen to be?
There's three satellites, and these are the weather satellites that they used for monitoring the weather in the
so 122, 104. Mm-hmm. Wow. So every year, not every year, it's like every week we have them, right? Maybe even every day, possibly somewhere in the world.
What, lightning?
No, these fireballs.
Yeah. So something like close to 50 tons of material, 50 imperial tons of material enters the Earth every day. So we're seeing little meteors that are entering the atmosphere, and you can see them, and they're often associated with comets and with asteroid belts. Asteroid that have usually they're associated with the orbits of comets, with the Earth coming close to the orbit of a comet, and they're little fragments of that object.
I think I understand what's happening here. The one in the middle is stereo, and that means it's detected by more than one GOES satellite, like GLM-16, GLM-17. Here it's like only
so they only so it's it's the region where the two satellites overlap, and so they're able to resolve better information about it.
Yeah, so if I say here, let me go with a high confidence one, show more info. Wow, there's a whole lot of detail. Like,
is that a time series? Is that
this is lat longs, the duration.
But what's the lower one? What's the lower graph? The graph below.
That's lightning energy. But
as a function of time during the day.
I think that's detecting the actual meteor, right? Is it?
I don't think that's meteor. I think that's lightning.
You think so? Okay.
Yeah.
No, it's bolides. Bolides are.
Oh, they are meteors. Okay.
They are. Yeah. This page. I guess they're measuring in terms of lightning energy. but it's actually the energy detected of the flying object.
Right. So you should see more in the places where the Earth is, where the Western Hemisphere. If this is in the Western Hemisphere,
This is like over here. It seems.
yeah. So if that point is then pointed in the forward direction of the Earth's orbit, then you should see an increase in frequency. I'm trying to understand the meaning of that variation throughout the day.
This is not. This is like the fraction of a second, I think. Right?
No. What is the x-axis on the lower scale?
It's time.
It's time of day. Right.
Right. So if I start from here, this starts from 14:39:27.
So that's around 2:30 in the afternoon.
2:39, and then the very last one is also 2:39:27:40. Yeah, it's like 0.314 seconds later. So this event that was detected was like less than half a second.
So you're trying to tell me this is one event?
This was one event. Yeah.
Oh, I see. Okay. All right.
I guess this instrument is really sensitive.
So it's very interesting. What I really don't have any idea. What is the meaning of that structure?
I think like how is the instrument essentially just detecting how much light there is and then correlating that somehow to how much energy?
I don't know. I just saw the website and I thought it was cool and I thought it was a neat thing that we could talk about.
I think that would make sense. Okay, so yeah, like so this top graph is from the GLM 18, and then you go down here, and then it's like the other satellite. I mean, since it's a constellation, right? The GO satellites.
Yes.
And so this is the other one that essentially has a similar plot. So, interesting. Although this one's, yeah. I guess for anybody who has any interest, you could really spend a lot of time digging through this data. Now, what can we do with this, though? Why are we even interested in tracking all these?
Well, I mean, the lightning is of interest because that's thunderstorm activity, and so that's the actual reason for tracking it. So there's interest in the meteors because they are essential elements of the history of the solar system. So at least that's why they'd be of interest to me. But the lightning itself is for weather prediction and weather monitoring.
Okay.
Right.
Yeah, like there wasn't specifically an instrument that was made to find these. They're just using it, right?
It has that characteristic. Yeah. Now I know the military tracks these kind of things because once upon a time we talked about the Vela incident.
Indeed.
Yeah, and so but this is not what this is. This is a civilian weather satellite that's used for monitoring the lightning activity.
This is a stylized image of what it looks like, which is you would never see it look like this.
No. I have seen meteors. There's several different kinds of meteors. Now everybody knows what a meteor is. I mean, a meteor is
meteorite, asteroid.
Yeah,
meteor.
So if you just see it in the atmosphere and it doesn't reach the ground, then it's a meteor. And if it reaches the ground, then we call it a meteorite. In other words, the actual physical material that's recovered. But that's very rare. Sometimes meteors are big enough to hit the Earth and they make the news, or they would make the news if it happened. For example, it could be a mass extinction event.
What is that event? The one in Russia called again?
Chelyabinsk. I don't know if I'm pronouncing it right. It starts with a C.
Chelyabinsk meteor.
Yeah,
event.
And I think it was in 19.
That one knocked out glass and everything.
Yeah,
right?
yeah.
Let me see if I can find a video of it. Here, let me. Okay. Meteor strikes Russia, over 1,000 believed injured. So it even injured people.
Yeah, right. It broke a lot of glass and set off car
Here,
alarms.
let me
And
see if I
I think
can.
there's lots of video of it because
Okay. Okay, so here I'm gonna share this because this
that's
one
not a
looks
bad idea.
amazing. Hold on a second, let me share it real quick. Like, look at that. That's what you would have seen on that
That's
day.
right.
Like, that's crazy. If I saw that, I would be. Well, I don't know what I would be doing. Like, that's during the middle of the day. Like,
Yeah.
oh my goodness, right? Like, yeah. So, like, literally, yeah, shattered glass. That's some real. And then,
Yeah.
yeah, like some school kids, I guess. So that is that however many kilotons of fireball explosion in the sky, because that one exploded in the atmosphere, right? Like it didn't actually hit the ground.
It didn't hit the ground, and I don't think that any pieces of it were recovered on the ground, but I could be wrong about that.
So just imagine like you being on the like seeing all that flashing right by you.
Yeah.
Oh wait, did that? I don't know, but I guess it's showing.
Yeah, pieces of glass and things like that.
Here,
so
skip forward.
that's the kind of thing that could happen,
I mean, these things, they could, if they were bigger, they could kill you. Okay,
well,
so that's graphical depiction.
The event that was experienced in kind of north and east of this region in 1908 was the Tunguska event, and I think it's just a coincidence that it's in the same region of the Earth. So
that's okay. I guess there's a lot of footage of people just taking videos from different.
Well, yeah, this was I think 2013.
Yeah,
was when this occurred, and so there was there's a lot of cameras and.
What is this?
Around.
Oh, these are like we track a lot of the space objects that's going around Earth. Yeah, but I don't think that one was not predicted at all, right? Like it was.
No, it was a natural object. It was not a piece of orbital debris.
What I'm saying, orbital. Go ahead.
I was going to say orbital debris is not. This is orbital debris. It's not likely to cause an impact like that Chelyabinsk meteor, but this is kind of a problem that NASA is working on.
I like this video. Like I can just imagine looking at that streaking across. That seems yeah. Okay. Well, that'll be some of the most dramatic sights if you happen to see one.
So one of the things that I wondered about that object was at the time I was thinking that it's Russia and we have kind of the West has an antagonistic relationship with Russia, and so evidently they knew that it was not an attack from a missile. They knew right away whether the Russian military had the capability of tracking this event, but it certainly would resemble a ballistic missile in some respect, and so they evidently had the ability to distinguish. They knew that this was a natural object and not an attack. I sometimes wonder if something like this were to happen, if the Tunguska event was a comet that exploded in Siberia in 1908, and if it had occurred over a city, it would destroy the city. It would.
Yeah, the Tunguska event. I actually in 5th grade, I wrote a whole report on the Tunguska event. Mm-hmm. So we had to write about like the great mysteries of the world, I suppose, and that's the one I chose because
it certainly is compelling, and even though the pictures are black and white and it seems like it's over 100 years ago, and this kind of thing happens about once a century.
Flattened and like 830 square miles of forest. So yeah, if it had hit his city, like look how like destroyed all these trees everywhere.
Yeah, it would have killed
a lot of people.
It would have killed many people and would have resembled a nuclear explosion.
So the weird side of me thinks it's an alien spaceship that blew up.
Yeah, I know.
But of course,
but
you know,
you know,
uh,
that's not how we operate, Shen. We don't send.
but
I'm just kidding.
but this is interesting. Like, I mean, there's, like, there's been an analysis done afterwards, but it took many years for Tunguska event to be like even thoroughly investigated because it was so remote.
It's so
So
remote and
1927. So it took like over 20 years, right?
yeah,
For
before anybody
to
could get there. Yeah.
Yeah.
What I understand is there even to this day there are still charred remains of the trees that got burned up
Here's a
and
good
so
one.
forth.
So possible sizes Tunguska, so 65 meters in Chile. Now, this doesn't mean that the impact causing 65 meters would. That's like the direct crater that it created. So it
Well, I don't think the Tunguska event. I don't think that they found any crater.
really?
I think
Okay.
yeah, I think that they worked hard trying to
Oh,
find
sorry.
some.
These are not craters. These are the sizes of the objects
They
themselves.
think that's the size of the object,
Yeah,
and so I don't believe that. I think, and the same thing with the Chelyabinsk. I don't know if the
Yes.
Chelyabinsk object was if elements of that were recovered or not. And so
Yeah, this is a good representation. Like possibly 50 to 80 meters, Chelyabinsk 17 to 20. The Chelyabinsk, you saw how like we saw that image. That was like a half or a third the size of the Tunguska meteor, and yet it still caused such significant damage. I mean,
and they have there for the scale also the Beringer crater in New Mexico or Arizona. That's the there's a crater in the western states of the United States.
Beringer crater. What is
Beringer.
That? Is that the?
Just Google that.
Is that the Beringer?
Big meteor.
Have I been there? Meteor crater. That's what they call it. I've been there.
Yeah,
I should find some of my old photos. Except I don't have an aerial photo like that. But I did go down there since I have a park there.
Oh, that's cool.
Yeah, I did like I was on a road trip with my dad, I think, and my sister, and we stopped by there. Since I was like meteor crater, we have to go there. So that's what it is, right? Yeah. So it's very well preserved since it's in the middle of the desert.
And it's relatively recent. It's something like 60,000 years ago.
Yeah, and there's still some fragments here because this one actually impacted, obviously.
Right.
You can see it. Okay. I know normally we do the show really long, but today I think we're gonna wrap things up.
Yeah. I was just up for a short little
why not, right?
Too.
Okay. Yeah. So with that said, I'm gonna I'm gonna jump over the UFO part because we already talked about the Tunguska event.
Yeah, well, okay, there you go. That was it's all right.
I need to find the report that I wrote from like a while ago.
That would be awesome.
I thought that would be like a 5th grade level of writing. I wonder. I must have improved by now.
We can do another show this week if you like. Since
we can definitely do that.
We've both been under a kind of like a lot of schedule pressures and stuff like that. So I would like to get more.
With all that said, I have to. So I do my exercise classes. So I gotta go run off to that.
Yep.
Not saying that space is extremely important, and it's good to hopefully, guys, just leave behind any comments you have. Oh, okay. Let me say. Okay, here's a few comments I didn't even notice. Alicia said, "Anyone out there a 617?" Yes, of course. Wow. I've seen a few fireballs in my life. Nothing like that. Poor dinosaurs. Yes, they died due to a giant great meteor. Sad people got hurt, and
me too.
Nanu. Okay, wonderful.
Yes, Orson. Right.
All right. Thank you, Alicia, for putting all these comments. For anybody else who's watching this now or later, please put any questions you may have. I will definitely look at them.
if anybody, actually, why don't we ask this? If anybody has a topic they'd like to have covered.
Oh yeah, if you have a topic in mind,
Mm-hmm.
put them in the comments. Why not? Topic in mind for the next show, put them in the comments. That's actually a great idea. I don't know why I've never solicited that. Okay, if you have any comments, if you have a topic in mind for the next show, put them in the comments. I put that there. And so this has been SG2 on Space, the only weekly space show. So hopefully, support us on patreon.com/SG2 on Space. Thank you again, Kyle Baker, Sam Welsh, John Graves. You can watch it on youtube.com/eshinga/streams, or you can look up SG2 on Space. All episodes that has Leonard will be on there. And any episodes beforehand, you can look up SG2 on Space, and you will find a number of episodes without Leonard. Since and he's like, yeah, sure, but yeah. So if you want to watch the first 100 episodes, which 120 or something, which did not have Leonard, you can. It's online as well. All right. With all that said, and Chip Burge. Oh wow,
Ball lightning. Okay. All right.
Okay, we can talk about that at some point. I actually have a really strong interest in that.
Yeah.
It's another great mystery.
That's a good, yeah, it is a great mystery.
Yes, indeed. Huh. Okay, I have some weird theories, but we can talk about that when we talk about that, when we talk about that topic. All right, with all that said, everybody, to the people from 10,000 years in the future, well, I'm sure you already know.
They're always in my mind. I mean, we're always thinking of them.
Indeed. And I really, you already know everything. So this for you is just an anthropological study.
That's right. And fashion, fashion study. So
exactly. So
cultural things.
All right.
Good night.
With that, good night. There you go.
Namaste.
I was waiting for that. All right.
Yes.
Namaste.
Shalom.
All that. Oh, nice.